Okay, so we move on to our next speaker, who is Reinhard Peiling, founder of Kite Swarms and Mozero, with more than 15 years in experience in R&D in AWIS, for both in academia and industry. So he's going to tell us about the progress along the long and windy road. So please give him a clap. Thank you very much.
Yeah, so hi everyone. Today I'm also going to start with a little bit of history on how this all got massively out of hand. It used to be a hobby. Like as a kid, I used to build kites, and that was the fun bit. Like the biggest gift I got as a child was a sewing machine, so I can build some flying things in the spare time, and that was basically the start of it all. But I had no idea yet of where this was going to go. So as a hobby, I was making kites, and as a student, I was studying product development in Antwerp, and I needed to have a topic for my master's thesis. Around 2008, we had to pick something. And airborne wind was a emerging topic back then, where there was a cool application for kites with product potential. And I had to find a topic to spend a year on, so I chose the topic of what does an ideal airborne wind energy device look like with the state of knowledge of 2009. And obviously that was floating offshore with a hybrid soft kite thing. So I spent a year designing a thing in 2009 that looked like, well, obviously it was a product design study thing where looking intriguing was important. But my promoter there at the Antwerp school was Moritz Deal. So then he lured me into starting a PhD topic on his dual kite research, which was amazing. So at the time, he was mostly looking into ways of starting multiple kites together, where rotary takeoff and landing systems start to make sense. My background was not in numerical optimization. So the shock of ending up from a product design group into a heavily mathematics-based group was, well, it was significant. So I was bringing a lot of real-world stuff into the mathematical optimization group and looked into actual practical ways of, well, getting stuff airborne. And that's where the rotary takeoff and landing stuff for rigid wings actually got a little bit further under the ERC Highwind project. But yeah, the hardware component was non-existent at that time. It was a small rotating arm device to get some lab results. Can we actually control this stuff flying indoors? But yeah, not very experimentally, well, it was an experimentally friendly system if you were the engineer that had originally built and designed it. And then, yeah, good luck after that. So that was the state of the art in 2011. But I was just sitting behind a computer coding stuff. Not really, well, oh, and then getting talked into Moritz of organizing AWEC 2011. So that was the biggest networking activity in airborne wind that one could do at the time, was email everyone, please send stuff. So I have the deepest respect for the organizing committee here that has gone through it multiple times. It's a great achievement to actually keep everyone coming together every time. So yeah. After that, after organizing the AWEC, I decided to not do that anymore and go and build some real stuff. So there was a job opening as a kite designer at Flysurfer Kiteboarding, which was originally my dream job, to become a kite designer. So I designed and built real flying devices that were built in series production. And yeah, my biggest passion project was actually single-skinned kites that didn't exist at the time too, because I was fascinated by building the lightest kites possible, because I was still convinced that also for airborne wind that would be the trick to get anywhere. And ironically, now we're probably flying the heaviest kite per square meter that you can possibly fly. But yeah, then years went on actually building soft kites, and airborne wind field from an outside perspective then felt reasonably stagnated, and nobody was doing dual kite stuff or multiple kite stuff, which Moritz really ignited this passion about it in me that was like, why is nobody actually building this? Like, drones have got so good. We can totally do this in a couple of years and build a 100 kilowatt product, and it's going to be amazing. So I founded Kite Swarms in 2017 with a group of Moritz's, yeah, well, the ones that grew up under Moritz really as students, and then started working on practical ways of actually starting multi-kite systems and stacked multi-kite systems, and together with the University of Freiburg look at the actual potential of scaling through attaching multiple kites together. So that's where Joachim and the guys of Freiburg are still doing great work looking at ways to do that. But yeah, hardware was still a problem. So we were flying stuff in a lab indoors again, quadcopters, looking at ways to actually do this. And then I started talking to Ampix Power, because they had built the AP2 that worked and did fault handling, which sounds good if you start flying multiple kites together. There's a good reason why you want to be able to detach from the tether and just land if something doesn't work out the way you hoped it would. And I just wanted to build to buy some kites, to buy some AP2s from Ampix Power to build our system upon. And that's how I rolled into the Ampix Power ecosystem, supporting them along the way, because the funding situation of Airborne Wind also wasn't pretty along that time, so it was better to collaborate and put resources together, and that's how I got in there. For a little bit of other context, like the significant events that have steered this path towards Mosaico is this drive for the value of, well, the difference between building small systems and big systems. And that's where you see things go slower and slower over time, where people start with something small and then decide to build something big, and suddenly the beautiful tact of 2 years between great progress events turns into 8 years between the start of it and either a great thing happens or nothing happens anymore. Don't have to say more about that, but that's been the tact a little bit from where I'm standing. Is like, people start building really big stuff under the high commercial pressure to scale up that might have been slightly too soon. So for reference, the EP2 has got less than 1,000 parts, which is a reasonably uncomplex machine. It does what it does fault handling, it can just land if something breaks, or it can still continue to fly, it can solve problems on board, it just works. So Ampix built 2 AP2s that had more than 500 flights, and they both still exist, albeit one hit a rock at some point in a field with a slight dent in the front wing, but that's it. They're still there. So that's was a good basis to start actually building AP3 with more than 20,000 parts that all interact. And yeah, that was not the easiest thing, but then working towards an AP4 megawatt scale system with another 10x improvement in complexity, that's it isn't the easiest path to manage when you go from, well, a very easy system in amount of parts to a giant complex system, which is where the analogy to the air taxi space is actually kind of good to make, just to see what they achieve with how much money and how many people and the amount of years it still takes to get anywhere. So it's with similarly sized systems with a factor of order of magnitude more funding, they have achieved arguably equally exciting results so far, which is where, if not for the funding shortages of Airborne Wind, the delays in the development process of AP3 would not have materialized as much. So the actual development timelines would have been identical to for example, the Lilium prototype development. So going through, actually just designing the thing takes multiple years with an awful lot of people, and then starting to build and verify the subsystems is an equally challenging thing if you have to design and build the technologies yourself. And then the business development comes in, where big stuff with more zeros is great. Yeah, that was basically the Ampix Power plan, was get to multi-megawatt scale really quickly by not commercializing smaller stuff. And that was, from a theoretical funding perspective, was the way to go. The multi-megawatt system sounds great, but you also have to have something to show for it in parallel, which was not, well, they were getting there, but not fast enough. And yeah, the funding situation wasn't sustainable. So therefore, yeah, the road to multi-megawatt fixed wing stuff in one step was not the way to go. And that's where the Ampix Power story really ended. But the opportunity in what has been done is there. Like, Ampix Power did a magnificent job at actually developing all of the technologies that were necessary to build multi-megawatt offshore systems, and did their homework really well, because most of the technologies didn't really exist off the shelf at the time when they needed them. The battery improvements, like the amount of space you have in the fuselage is for the batteries that you need on board, and you need to be alive. The power densities only have increased massively in the last couple of years, but AP3 was designed in 2017. So yeah, a lot of homework needed to be done, so a lot of resources were put towards building technologies that today would be slightly easier to source, but you also need to have the money for it. So sometimes it's easier to just have the guy that you already have on payroll do the thing, because that's a fixed cost anyway. So then you start to do a lot of in-house stuff, which may or may not be the right way to do it, but it's what has been done. So an awful lot of work has been done on actually solving the problems of megawatt scale fixed wing airborne wind. Would have been a pity to just let it die on a hard disk somewhere. This combined with the actual very rigorous culture of Ampix Power, of doing things the aerospace way, document everything super rigorously, really rigorously. It's the amount of documentation is unfathomable, but it's there. And that's also what gave it a shot at still existing today, because without that, if the people disappear, the knowledge disappears, and then good luck trying to do anything. So yeah, an incredible amount of work and documentation existed on the fault-tolerant controls, the aviation processes, certifiable architectures, and so on and so forth. It's been looked at, and it's there and it's ready. And this combined with just the track record of AP2 doing all these quasi-incidentless flights, and AP3 rolling on the runway. The actually flying AP3 was within sight at the end of Ampix Power. It's like just, it was moving. It was a moving machine. It looked like it could fly. It was a couple of months away from actually starting to fly. It was just not defined how many months. So then, yeah, get together with the group of core engineers that actually can do all of this stuff. So we fully scaled down the necessary team to the absolute bare minimum to get AP3 airborne, because that was what was everything everyone wanted to continue. It was just see this thing fly. We've been building it for multiple years. It moves, everything kind of works. We just need to finish it. And then we finished it. It was a massive exercise in perseverance to actually get through it. But turns out it's the perfect motivation to have a machine that's exciting to work on, to keep people motivated. But in practice, that meant that we were rolling AP3 along the runway for slightly more than a year to fly in 2D before flying in 3D, because you don't really want to lose the plane either. So everything needs to properly work before trying to fly the big system. It also took a year because we applied for the actual permit to fly AP3, which in Europe is a process that everyone knows really well. And our original plan was to fly in Spain, sunshine, no wind, test site with no one there. It was a very appealing perspective of going somewhere nice to test. So we applied for the authorization to fly in the Netherlands because the company is based in the Netherlands and you need the authorization from your national authority where the company is first before you can apply for a cross-border anywhere else. So with that, they said it would take 12 weeks. It took 12 weeks. And then we applied for the same permit in Spain, and we got it 2 days ago. So that's the difference in, well, just, yeah, it's for a planning from a planning perspective, it was unpleasant because we wanted to fly last summer when it was quite nice, everything was booked in Spain, and then we weren't allowed to fly in Spain. But luckily, someone put in a new runway in the Netherlands in a field that previously was a grass runway, and then they put in an asphalt runway in Ostwald Airport, which enabled us to find an area that was sparsely populated within the Netherlands to do our initial flight testing that was comfortable to fly on, with a logistics operation that was manageable, because it's the same country. It was still very far away in the same country, but it was manageable. With also the end of November in the north of the Netherlands, which means it's not exactly Spanish weather. So we moved everything there, and then it rained for a while. So you don't really want to fly for the first time in adverse conditions, because we really wanted to have a silent air mass to just fly under its own power for the first time, and then go from there. So turns out it works. So yeah, after all these years, actually taking the decision to take off from the first time, that was the biggest emotional stone from the stomach relieving moment. That was there, and that was it's pretty remarkable that it just also landed in one piece. Like like, so you somehow you don't really, well, you're imagining all sorts of things. Of course, it's going to be the greatest thing that helps solve the energy transition, and at the same time, during this couple of minutes flight, you're standing there like, I really hope this is not going to be super awkward. So yeah, it worked. But so the 3 arrows there are there to indicate what it actually would take to take AP3 to the end of the things. And we've now done the first 2 bullet points of the list. So we have a lot of work to do to actually get there. But it's there. The plan exists. The basis is there. It can all be done. I don't know if we still want to show the video. I can do that at the end of the
1 2 minutes.
Yeah.
That's all the time we have.
Yeah. So yeah, and that's where the expectation management thing comes back in. So now we've flown, so there is, yeah. Now we can scale, right, and go back up. So that's not what we think is what's necessary in airborne wind right now. So we need reliability, practicality, and show for it and build it up to not do the same mistakes that others have made in the past. So we are currently still very much in this loop of getting mature enough to convince customers to then attract the funding to then actually build the product. So we are getting to that technological maturity through actually executing the research plan of AP3. And we just have to continue executing it whilst not accessing the necessary funding source to actually take it forward, which is the exercise everyone is going through in the industry now. So that's why we are proposing to really start using AP3 as a springboard for innovation for the industry itself, because we don't need to do this alone. It's a well-designed machine, but it's not the product. It's far too complex to be a product at that scale. So there is a lot of potential to do stuff together. Like if you just want to work on wing profile optimization, why don't you take the basis of this and just change the wing profile and do your simulations on that and see how it compares. There's tons of data that can be done, or if you just want to fly a certain trajectory, follow the trajectory, and it exists. But if it gets combined in combined research, operations, applications, it solves the hurdle towards this VC funding gap. So yeah, just for reference, I just include the spec sheet list here of the stuff that exists for AP3. So it supposedly has a rated power of 150 kilowatts. We'll see what it actually turns out to be, but the peak power is 600 kilowatts. So it's a big gap in machinery. So yeah, the ground station there as well. It's a very capable one. And yeah, then I've alluded to it yesterday. Like it would be, for us, it's a very good exercise to be integrating all the lessons learned from doing all of the megawatt scaling and re-implement it at the small scale where everything started, and make something that's not complex, not overly complex and manageable, and can serve as a basis to build upon. So if you guys want something like this, we can totally do it, and it would be nice to do it together, like get some feedback from you guys to see what it actually needs to be able to do in the first stage, second stage. But from a technological perspective, this is a solved problem. So yeah, that's the invitation to collaborate is there. Accelerate the timelines, use the stuff that has been done in the past, and yeah, that's it.
Okay, thank you very much, Reinhard. I had to give you some extra time due to the Spanish speed administration issues. So, any questions? Yep.
Thank you very much, Roland Schmel from TU Delft. Would it be a very nice presentation, by the way? You can really see the designer here at work, very well presented, and nice pictures. Would it be an idea also to do the same as Makani did, to open the entire IP pool, and by that really boost and make it possible, boost the development, make it possible that others actually jump on that track and start off where you were, and not only then as one company but as many?
Well, it depends on the definition of the IP pool, right? Like we want to get to a stage where it's also a sustainable business, because we need the funding to get to somewhere. I don't think we can do it alone. We would probably collaborate and work together with other companies that do the same thing. But open, just the AP2, AP3 data, it's all there. There already have been tons of publications on what it can do, the reference model stuff. There's a lot of stuff that has been going on. Yeah, we just need to focus on the core things that we need to keep as a black box, and the other stuff we can freely open up. It depends on the embodiment. That's yeah, we'll find out.
Okay, thank you.
Okay, some other questions from the audience? Yep, one over there, Christina.
More than a question, it's a comment. So in conventional wind right now, there's a similar push as you're describing to make wind turbines bigger and bigger and bigger. And it's funny, what you were saying is what's been said already in the conventional wind world, which is, when do we stop? Because the reliability, safety is going down the drain if you just have to make bigger blades, bigger, bigger, bigger. And so now even within the conventional wind, they're putting the brake on size. And they're like, we don't even have the infrastructure, we don't have ports big enough to transfer these things. So I think you're taking a very safe route to stop a little bit, maybe megawatt, whatever. We'll worry about it later, but let's make these steps safe and reliable. So I just wanted to comment that it sounds like a wise idea.
Yeah, I want to join to Christina's comment. I think in conventional wind energy in the 80s, 1980s, we tried to do too big, and we collapsed. We realized it wasn't possible. It took us 40 years to get to units of 20 megawatts that we are using now. But yeah, it took 40 years to get to this point. So maybe with Airborne, we need more time as well.
Yeah.
Yeah, okay.